This is more factoring completely. Before you can factor and solve, you must get the equation equal to 0, so we're going to have to subtract 50x. So we get it on the other side. So it's 18x cubed minus 50x is equal to 0. Now, by looking at your flow chart, the first thing we do is look to factor out a GCF. There's a common factor of 2x. 2 goes in 18 9 times, x goes in x cubed, x squared, minus 25. Now, 9x squared minus 25, that is a difference of two perfect square. Bring down the 2x, and 9x squared minus 25 factors into 3x plus 5 times 3x minus 5. Now put each one equal to 0 and solve. And you're going to have three answers because look at the highest exponent in the problem. The highest exponent is a 3. That, whatever the highest exponent is, that's going to tell you how many answers you're going to have. Divide by both sides by 2, and you get x is equal to 0. Second one, we're going to subtract 5, divide by 3, x is equal to negative 5/3. Add 3, add 5, divide by 3, and x is equal to positive 5/3. We have to get, example 5b, we have to get it equal to 0, so we're going to add 64. Now, do we have a GCF? Is there a common number that goes into 9, 48, and 64? There is not. But 9 is a perfect square, and 64 is a perfect square. So I think this might be a perfect square trinomial. So I am going to treat it like that. Square root of 9 is 3x. Your signs are both going to be negative. Square root of 64 is 8. But I have to check. Negative 24x and a negative 24x is a negative 48x, and that is my middle term. So now I have to solve. Because these two binomials are the exact same thing, I only have to solve one equation. So x is equal to 8/3. So the other answer is going to be 8/3 too. I have two answers, they just happen to be the exact same thing. Example 5c, I don't have a GCF, but it looks to me like this is a perfect square trinomial that factors into two identical binomials, where both sides are going to be positive. Square root of 36 is 6. Let's check it. 6a, and my answer is 6a, which is 12a, and that's my middle term. So now, I'll just put each one equal to 0. So a is equal to negative 6. Now, I know with the fractions, this particular problem looks a little complicated, but look at 9 over 16. Is 9 a perfect square? Yes. Is 16 a perfect square? Yes. So 9 over 16 is a perfect square. It's 3/4 times 3/4 is 9 over 16. So we make our two binomials. Your signs are both going to be negative, and the square root of 9 over 16 is 3/4. Now look, if you check it, that's a negative 3/4 x, and your end term is a negative 3/4 x, which is a negative 6 over 8x, which reduces down to negative, it's a negative 4. and that reduces down to 3/2, which is your middle term. So after I check, I'm going to erase this. Put each one equal to 0. I'm going to add 3/4 to both sides. So x is equal to 3/4. Okay, on this one, I am going to look to see if I have a GCF. I do not have a GCF. I'm going to factor by grouping the first two together. I'm going to rewrite this. And grouping the last two together. Now I can factor out a g and get g plus 2. And I can factor out a negative h and get 3h minus 4. But these two are not identical. There is nothing else I can do. So technically I could not factor this. So it is prime. Number 2, I am going to factor out a 3k, and I get k squared minus 12k plus 16. Now, this I can factor into two binomials. My signs are the same, they're both negative. Perfect square of 16 is 4 and 4. Let's check. That's a 4x, and that's a 4x, which is 8x. Is that my middle term? No, it is not. So, this is not a perfect square trinomial. So I have to list all the factors of 16. Okay, I made an error right here. 3 goes into 24 8 times, not 12. Okay, now it will work. So that's a negative 4k, and a negative 4k is a negative 8k. Okay, and that is the end of day 2 on factoring completely.